threads work in two ways. Either it's a preemptive threading or it's a cooperative multi-threading. In a preemptive multi-threading, all threads get the chance at the CPU time. It is a time shared process. Each and every thread gets some amount of time for execution. Depending on the JVM implementation, either this could be queued or it could be randomly picked as to which thread gets to execute next. But let's say a higher priority thread comes into picture, then automatically the higher priority thread gets the CPU time first. So how does the priority make a difference? The higher the priority, higher the preference at the CPU time. So the highest priority thread gets the CPU time first, and after which the rest of the threads get their CPU time. So it could either be queued and one after the other the threads could be executing, or it could be just randomly each of the threads get some CPU time to get executed. That is preemptive multi-threading. In case of cooperative multi-threading, what happens is the highest priority thread always gets a CPU time till it is done with. Then only the rest of the thread get their CPU time. That is, the next highest priority thread gets a CPU time. So it's always a selfish thread in cooperative multi-threading. If in case the highest priority thread goes into a sleep state, then the next highest priority thread gets a CPU time to execute during that point of time. Once this highest priority thread which has gone into sleep state comes back into running state, again it gets the CPU time. So it always rules the CPU time. Now remember, we are placing threads into a thread group. The thread group class has similar functionalities as a thread to operate on group of threads which belong, set of threads which belong to that particular group. Not only that, it also has active count, all the count of threads which are available in that particular thread group. And it also has a method set max priority. Now let us see how this set max priority works. Let's assume I have thread 1, thread 2, thread 3. And let's assume all these 3 threads belong to a group called TG1. I would have created thread group TG1 is equal to new thread group. And while creating these 3 threads, I have passed TG1 as a parameter. Now let's say I set the priority for T1, set priority of 9. Let's assume that then I say TG1 dot set max priority of 8. Then we say T2 dot set priority of 9 and T3 dot set priority of 6. Now if I were to, after this, display what is the priority of each one of these threads, you would find out that T1's priority is 9, whereas T2's priority is 8 and T3's priority is left at 6. The reason for this is you are setting the priority of T1 to be 9 before setting the max priority of for the group to be 8. When you set the max priority for a group, it means to say that any thread that belongs to that particular group cannot have a priority greater than 8. Although the allowed priority is between 1 and 10, you are setting any thread belonging to this particular group can only have maximum priority of 8. But this particular thread also, T1, belongs to TG1. but its priority has been set prior to setting the max priority of the thread. So at the point when you set this priority, the max priority was 10. Okay, so if you are setting the priority of a thread after setting the max priority, and that priority which you are setting is greater than the max priority, it does not throw an exception. It just takes it as a max priority of the thread group. As long as it's within the max priority, it leaves it as it is in case of thread 3. Now after all this, if you were to reset the thread 1's priority again, at that point the max priority comes into picture, or it takes an effect. So this is how max priority works. Any thread which is a daemon thread, within which if you were to create another child thread, that also becomes a daemon thread. A child thread of a daemon thread is always a daemon thread. By default, therefore, set daemon is false. If you want to check whether a thread is a daemon thread or not, you have is daemon, which returns true or false. Now what is the difference between a daemon thread and a user thread? Why do I need to create daemon threads? You might have heard of daemon processes. For example, Unix has daemon processes. One of the daemon processes responsible for updating the system block of the Unix environment. It updates the system block every now and then of the Unix system. Daemon processes or daemon threads are basically responsible for managing resources. For example, when I start up my JVM, inside the JVM process there is a garbage collector application running. Garbage collector is a thread and it is a daemon thread, because we mentioned that garbage collector application starts when the JVM is started, and just before the JVM is shut down, the garbage collector application shuts down. So what does it do, the garbage collector? It manages memory. So daemon processes are used to manage some resource, and when I manage a resource, again and again I execute the same set of instructions. So in case of a garbage collector, it does mark and sweep every time it executes. So therefore there should be a loop, while true loop for daemon processes. So in a while true loop you place the code, because if I am just going to have a daemon process execute something and come out, there is no point making it a daemon process. It can just be a user thread. I just execute and exit out. That's about it. Where I need to manage a resource, it has to happen the entire time my application is running, again and again. My garbage collector has the lowest most priority, that's priority 1. That's why even when we call GC method from the system class explicitly, there is no guarantee that particular instance itself it will invoke the garbage collector, because it has the lowest priority. It needs to get its CPU time in the due time. So in the due time it will execute, not immediately. That's why we say there is no guarantee of executing even if you call GC. So you can also say now, if you want to write a while true loop and execute your your code to manage some resource, why not do that in a user thread itself? Write a user thread, inside the user thread write a while true loop doing the same thing again and again. What difference does it make? The difference is the JVM is alive as long as the user threads are alive. So if you put in a while true loop in a user thread, which is an endless loop, you are not breaking out of the loop at any point, you will never come out of program execution. So your JVM will never exit. Your program never ends. Whereas when you put the same while true loop into a daemon process, what the JVM does is, it checks as long as all the user threads are alive, it has all the daemon threads running and the JVM is alive. Once all the user threads die, the JVM will take care of killing the daemon threads and exiting out. That is where it's going to make a difference. You are not to kill the daemon threads, it throws you an exception. The JVM will take care of killing the daemon threads. That is the difference between daemon threads and the user thread.